if we want to find the second derivative of secant x, first thing we have to do is find the first derivative. So we should know what the first derivative of secant x. You all assured me that you'd have these memorized when you came in today. So what's the derivative of secant x?
Secant x tangent x.
Okay, secant x tangent x. Good. And so now if we're going to find the derivative of that to find our second derivative, then we need to use which rule? Product rule. So we'll take secant x times the derivative of tangent x, which is secant squared x. And then we'll add to that tangent times the derivative of secant x, which is secant x tangent x. And simplifying that down, we got we could factor out the secant x from both of them if we wanted to. Secant x times secant squared x plus tangent squared x. Everybody good? Should be able to use our product rules and our quotient rules and all that stuff, even the reciprocal rule in conjunction with the derivatives of trig functions. Any issues there?
Nope.
Okay. And I've been having trouble again today for some reason. The chat doesn't pop up necessarily if you type something. So if I don't answer your question in the chat, just yell at me and tell me that I didn't answer, and I'll go in and look. Or you can just ask me the question out loud too. All right, so let's apply this just a little bit. Let's find the equation of the line that is normal to the graph of y equals tangent x at the point pi over 4, 1. So if we're looking for the equation of a normal line, what are the two things we need? We need a
tangent line.
Well, we need the slope of the tangent line, right? We need a slope. Anytime we need to write an equation of a line, we need a slope and we need a point, right? We got the point as pi over 4, 1. We need to find the slope. So if we find the slope of the tangent line, we should be able to take the opposite reciprocal of that to find the slope of the normal line. So what's the derivative of tangent x? Or let's say y prime.
Secant square.
Secant squared x. Yep, and if we're going to evaluate that at x equals pi over 4, what is the secant of pi over 4? And then we need to square it. So what's the secant of pi over 4? No. All right, what's the cosine of pi over 4? Cosine of pi over 4.
Root 2?
Root 2 over 2 is the cosine of pi over 4. And so the secant of pi over 4 should be the reciprocal of that. So if we flip that around, that should give us 2 over root 2, which is just root 2. Yeah. So this is root 2 squared, which is 2. So our slope of our tangent line is 2. So what should the slope of the normal line be?
-1/2.
Negative
or negative 1/2.
Yep, negative 1/2. So our equation should be y minus 1 equals negative 1/2 times x minus pi over 4. Good or no? Any issues with that?
Wait, I missed something. How'd you go from 2 over root 2 to just root 2? I was kind of catching up.
2 over root 2 is just, well, if you think about what's...
Oh, are you just
what's
rationalizing the denominator right there?
Yeah, I mean, lots of different ways to do it. One is to rationalize the denominator. One is just to say that, you know, 2 over root, that's root 2 times root 2 is 2, right? So cancel the root 2's. Or that's 2 to the first over 2 to the half, so subtract the exponents, which is 2 to the half. You know.
Okay, cool.
Lots of different ways to come about it, but yeah. Any other questions or issues with that? All right, let's find the derivative of this. Cotangent x plus cosecant x times tangent x minus sine x. How do you guys want to go about this? Should we use the product rule, or should we distribute first and then see what it looks like?
Let's use the product rule. I don't, distributing that looks ugly.
Yeah, I would say to distribute, because like if you do cotangent times tangent, then that kind of just like cancels out, and then cosecant times sine, and that would cancel out. So I don't know, but I think distributing it might help.
Okay, that's a good thought. It looks like a couple of those terms will cancel out. So what do you guys think? Anybody else want to weigh in? We got one for just product rule and one for distribute first and then find it.
Say distribute.
Distribute, another distribute. Anybody else? Yeah, distribute.
Sure.
All right, sure, why not? That's fine with me. Okay, so let's distribute it out. F of x equals cotangent x times tangent x. So that's cotangent times tangent. That's 1 over tangent times tangent. That should just be 1. Yep. Then we have cotangent times negative sine. So we got minus sine x times cotangent, which is cosine over sine. So we can simplify that in a minute. And then we've got cosecant times tangent. So that'd be sine over cosine times 1 over sine. So we could simplify that in a minute. And then we're left with cosecant times negative sine, which should be minus 1. Right? 1 over sine times negative sine should be minus 1. So that looks like that's going to be pretty helpful. The 1 and the minus 1 will cancel. Sine over the sine should just give us a negative cosine there. And this one, the sine over the sine should cancel again, and we just got 1 over cosine, so plus secant x. That looks like that's going to make that a lot easier, right? Oftentimes, simplifying these bigger trig expressions down is going to make our life a lot easier. If we'd gone through and used the product rule, we're going to have a giant mess. Whereas here, the derivative of negative cosine is just sine x, and the derivative of secant is secant x tangent x. So I would always recommend trying to simplify the trig before you take the derivative, because when you take the derivative with the trig functions, generally the trig expression gets more complicated. So the more you can simplify it ahead of time, the better off you'll probably be. Everybody good with that?
Yep.
Yeah.
All right, cool. Let's take a look at another one. Let's find the derivative of sine x over 1 plus cosine x. How are we going to go about that? Is there a nice, easy way to simplify that, or should we just take its derivative?
I'd say product rule.
Product rule or quotient rule?
Question, my bad.
Yeah, quotient rule. So let's do quotient rule. So we'll do the derivative should be equal to the denominator, 1 plus cosine x, times the derivative of our numerator, which is cosine x, minus the numerator, sine x, times the derivative of our denominator, and the derivative of 1 is 0, and the derivative of cosine is negative sine x, all over 1 plus cosine x squared. So what do we end up with here in the numerator? We'll distribute out the 1 and the cosine x to give us cosine x plus cosine squared x plus sine squared x all over 1 plus cosine x squared. Everybody good with that?
Yep.
And how can we simplify that?
Cosine squared x plus sine squared x is just 1, so we would simplify to cosine x plus 1.
Yep, in the numerator, and then in the denominator.
And then like cancel out in the, yeah.
Yep, so then 1 plus cosine over 1 plus cosine squared should just be 1 over 1 plus cosine. Everybody good there? Any questions or issues with that one?
At the end there, where does the 1 plus go in the numerator? Oh, never mind.
All right. All right, last one of these, and then we're going to take our quiz. So we want to find the slope of the tangent line to sine x at these different coordinates. Basically, I just want to know, do you know what your trig values are on your chart? And then we want to know when is the tangent line horizontal. So we've got y prime should be equal to what if y is sine x?
Negative cosine.
Positive
Oh,
cosine. Yep. And so at 0, cosine of 0 is 1.
1.
Cosine of pi over 3 should be
1/2.
1/2. Cosine of pi over 2 should be
0.
0. Cosine of 2 pi over 3 should be,
Negative 1/2.
and cosine of pi should be negative 1.
1.
And so when is the tangent line horizontal? At x equals tangent line is horizontal when the slope of the tangent line is,
Pi over 2.
or the slope is 0. In this case, that's at x equals pi over 2. Everybody good? Pretty straightforward?
Yeah.